Let's start Chapter 3. Linear equations. And inequalities. In two variables. So let us start section 3.1. Linear equations. In two variables. Okay, so first thing I should tell you is that, well, a linear equation in two variables, well, um, let's say the variables x and y. Linear equation, well, a linear expression in two variables. Let's say x and y. Is an expression of the form ax plus by, where a and b are constants, where neither a nor b is a variable, contains the variable x or y. So then a linear equation in two variables is just a linear expression in two variables equal to another linear expression in the same two variables. So in general, it looks something like ax plus by equals c or something. And so let's do some problems on page 104. Let's say problem number 2. In exercises 1 through 5, determine whether or not the given ordered pair is a solution of the given equation. And so 2x plus y equaling 4. And so in this case, we have, I want to check, is 2, 0 a solution? So let's replace x by 2, y by 0, and check if this satisfies this expression, this equation. And so 2 times 2 is 4 plus 0. That is indeed equal to 4. So yes, 2, 0 is a solution. Let's do problem number 12. Is x minus 4 equaling 0, a solution is 4, 0, a solution of the equation x minus 4 equaling 0. So let's check. Well, wherever I see an x, I replace x by 4. Wherever I see a y, I replace y by 4. There's no y, so I don't need to replace it anywhere. And so is 4 minus 4 equal to 0? Yes. So yes, 4, 0 is a solution to the given equation. Let me do, let's see, is there another one let's do problem number 8. Oh, no, is there one that doesn't have an x? How about problem number 15? Y equal 1. Is the point 31 a solution to this equation? Well, I replace every x by 3. There's no x. And every y by 1. Is 1 equal to 1? Well, yes. That certainly is a true statement. And so, yes, 3, 1 is a solution. Okay, let me do problem number, let's say 18. In exercises 16 through 29, complete the ordered pair so it represents a solution for the given equation. Okay, so I'm given the following equation. 2x plus y equals 5, and I want to complete this ordered pair. So I'll call this ordered pair, well, negative 3y, and solve for y. So I have x is equal to negative 3, y is just y. And so I have that 2 times negative 3 is a negative 6, plus y is 5. Add 6 to both sides of my equation in order to solve for y. So y is equal to 11. And so the ordered pair that solve this is the ordered pair negative 3, 11. Let me do problem number 32. And so in exercises 30 through 49, complete the table of values so that each ordered pair in the table represents a solution for the given equation. So problem number 32. So I have here the following. X, y, negative 1, 3, and 2, negative 1. Okay, so and the equation is x, let me put it over here, x minus 2y equals 3. Okay, so let's do this in the exact same fashion that we did in the previous problem. It's just in this case I'm going to have 4 differing values that I'm going to do rather than one for problem number 18. So basically we're very lazy and we can ask the same problem like 4 times just in a very small little table like this and say complete the table. And so let's see. Let's first do this when x is equal to -1. And so if x is -1, then -1 minus 2y is 3. Let me add 1 to each side of my equation in order to isolate y's. And so -2y equals 4. Divide by -2. And so y is equal to -2. And so -2. Let's figure out, well, if x is 3, what is y? And so 3 minus 2y is 3. Subtract 3 from both sides. -2y is 0. Divide by -2. So y is 0. And so I have here y is 0. Next, if y is 2, then I have x minus 2y equals 3. So x minus 4 is 3. Add 4 to both sides of my equation. So x equals 7. And lastly, if y is -1, then I have x minus 2y equals 3. So x plus 2 equals 3. Subtract 2 from both sides. So x equal, so x is equal to 1. And so I have completed the table of values. Okay, good. Now, let me give you the coordinate system. So, take any line in the plane. So let's say this line, and I'll call that the x line. Take any line in the plane that is not parallel nor coincident to the x line. Let's call that the y line. So just pick any line in the plane, and we don't want lines that are the same as x or parallel to x. And draw that line. I call that line the y line. The point of intersection between these two lines will be called the origin. These two lines divide my plane into 4 quadrants. The first, second, third, and fourth quadrant I can associate with any point in the plane an ordered pair as follows. Take a line parallel to the y line passing through that point. Find the point of intersection. between the x line and that line. Measure the distance from the origin to this point along the y-axis. We will call that distance x. Now, if we are to the right of the y-axis, I'll make it positive. If I'm to the left, I'll make it negative. Similarly, take a line parallel to the x-axis, passing through the point. Find the point of intersection between that line and the y line. Measure the distance from this point of intersection and the origin along the y-axis. Call that distance y. If we're above the x-axis, I'll make it positive. If I'm below the x-axis, put a negative sign in front. Now I can associate with this point the ordered pair x and y, those two distances, the two sign distances. I will call x the abscissa, the abscissa, and I will call y the ordinate. Okay. Now, it turns out that actually we have sort of gotten rid of the terms abscissa and ordinate, and we actually start to call these, well, rather than abscissa and ordinate, we'll actually call this the x coordinate and the y coordinate. Then we eventually got rid of the dash, and we actually made these into a word, which is the coordinate. So it's actually, now we call them the x and the y coordinates. There. So it's the x coordinate and the y coordinate. Actually, usually we now put a little dash there. So the x coordinate, the y coordinate. Okay. So the modern terms are x and y coordinates. So this is called a Cartesian coordinate system. Named after Rene Descartes. Now, it turns out that if the intersection between the x and y axis are actually at a right angle, then we will actually call these a rectangular coordinate system. So in general, we'll actually make the assumption that we're always doing a rectangular coordinate system. Okay. So let me do problem number 50. Plot the ordered pairs on the same coordinate system. So A is 3, negative 2. B is 2, 4. C, negative 2, 3. D, negative 3, negative 2. E, 5, 0. F, 0, 5. Okay, so let's draw these all in the same coordinate system. Okay, so let's do this. 1, 2, 3, 4, 5. Oh, we can actually go to 5, I think. Make them a little bit bigger. So let me label everything. So 3, negative 2. That's A. 2, positive 4. So I go in the x2 and the y4. So that's B. Negative 2 in the x, positive 3 in the y. That's C. Negative 3 in the x, negative 2 in the y. D. 5 in the x, 0 in the y. E. 0 in the x, 5 in the y. F. Okay. Let me do problem number 64. In exercises 64 through 88, find a relationship between the coordinates of the collection of ordered pairs. So I have here an ordered pair. And I want to see, well, what's the relationship between all of these numbers? 1, 0, 2, 2, 3, 4, 4, 6. So how is x related to y? So if I look at this, well, you notice that if I increase x by 1, I'm increasing y by 2. And so whenever I increase x by 1, I should increase y by 2. But when x is 1, y is 0, so I've got to subtract that extra 2. And that is the relationship between x and y. 2 times 0 is 0. I'm sorry, 2 times 1 is 2, minus 2 is 0. 2 times 2 is 4, minus 2 is 2. 2 times 3 is 6, minus 2 is 4. 2 times 4 is 8, minus 2 is 6. And so that is the relationship between x and y. Let me do problem number 80. When x is 1, y is 2. When x is 4, y is negative 1. When x is 6, y is negative 3. So what you notice is that if you just add x and y 1 plus 2 is 3. 4 minus 1 is 3. 6 minus 3 is 3. So the relationship between x and y is just x plus y is equal to 3. Maybe I'll do one more. How about problem number 86? X, y. When x is 1, y is 4. When x is 2, y is 8. When x is 3, y is 12. And so, you notice here that every time I increase my value of x by 1, I'm increasing the value of y by 4. So notice that, well, 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. So y is equal to 4x. Let me do, oops, well, no, I guess I'm done. Let's just say I'm done here. So now do group work. So you should do group work. And so this is group work 3.1. And this is due Sunday, September 11. And so the password is linear equations. Okay, so that's it. So that finishes off section 3.1.